Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about today's LeetCode problem, that is the lowest common ancestor of a binary search tree. This is a easy level problem and we'll understand what this question is asking us to do and how we can actually solve a question like this. So this is an easy level question and this won't be having much complexity, but understanding this question is really interesting. I'll make you understand exactly how you can think on finding a solution like this, how easily you can do those and how interesting the question is. So watch till end. This will be interesting as well. But before starting this video, make sure to subscribe to this channel for regular lead code videos like this. So the question says, given a binary search tree, so it says a binary search tree is given. So binary search tree means the root value like is the middle value, and all the value on the left and the root are less than the root, and all the value on the right of the root are less than the are greater than the root value. So you can see like there are 5, 3, 4, 2, 0, all are less than 6, and there are 7, 8, 9, all are greater than 6. So that's the binary search tree. So that's given to us. Okay, it's more or less you can think it's kind of a sorted order. Okay, if you know the order, then it's kind of sorted for you. Now let's look further. What we need to do with this? It says we need to find the lowest common ancestor, that is the LCA node of two given nodes in the binary search tree. Okay, there will be two given nodes. Look here, there are P and Q are the two given nodes, and this is the root, the main whole tree given to us. We need to find the lowest common ancestor of the binary search tree. So what this lowest common ancestor is like given a definition as per Wikipedia, that is defined between the two nodes P and Q. The lowest node T at uh, that has both P and Q descendants, uh, where we allow the node to be descendant of itself. Okay, so what it exactly means, let's understand this. Say you are given two nodes as 0 and say 5. Okay, so what's the lowest common ancestor? The lowest common ancestor for us will be 2. Fine, that would be 2. So as per the question, example 1, if you see the given nodes are 2 and 8. So 2 and 8 are the two nodes. What's the lowest common ancestor? Ancestor means the node above it. It's 6. Okay, so that's the answer to us. There's a 6. So other way, what would be the other way? Other way would be, see, say we are given two nodes, 0 and 2. Okay, so what will be the lowest common ancestor of this? So you might think that 0 and 2, the ancestor of 2 is 6, so we should go ahead with 6. No, we should go ahead with 2, because 0 and 2 have ancestor, like the lowest common ancestor is 2 itself, because the last line over here, where we allow a node to be descendant of itself. Okay, so that's the reason we go ahead with 2. Okay, if a situation like that arises. Okay, so the main idea is not like the idea is simple. Okay, we are given two nodes. What we'll check for each of the root. Okay, each of the tree root, or maybe the subtree, each of the subtrees, we'll keep on checking if both these nodes are less than the current root or are greater than the current root. Fine. So if it is if both the roots are less than the current root, then we'll move into the left subtree. Fine. If both the roots are greater than the current root, then we'll move into the right subtree. Fine. And if not, if we don't if we find that both the roots are on two sides, or not both the roots are not less or not greater. Okay, there isn't any condition of equal to, there is a condition only for less than or greater than. Fine. And we will need to check that for both the root. So if both the roots are not less or both the roots are not greater, then whatever the current root we are at, that's our answer. Okay, so that's our answer for this particular particular test case. So that's the way we should look ahead into it. Okay, so we need to check that if both the roots are less, then go with a particular one. Go with the left one. If both the roots are greater, go with the right subtree. Or if these two conditions fails, then simply go with the return the current root. Okay, so that's the understanding of the question. Now if we just uh, like look ahead into the complex constraints that we are given. The constraints are, see, the nodes lie in the range 2 to 10 to the power 5. So you are sure that there are two nodes at least. So there's no need to check whether this root node is null or not. So that condition doesn't hold in this case, because you are given that there will be at least two nodes for sure. Fine. And this is the range of the node value can lie anywhere, and it's also given that all the values are unique. So all the values are unique, that means there is no chance of duplication, or no chance that the values might be less than or greater than, or like there cannot be repetition of numbers. So there can be a double answer to our question. Okay. And also given the p is not equals to q. So p is not equals to q, that means both are not a single node. That's also possible. Okay, like like you may not think that both nodes are given to a single node. Okay, so that's not a case. Okay. Also it says like p and q will exist in the pst. So it's you can be rest assured that p and q, these two numbers given to us, will be there. Like it may not happen that you are searching for it and you didn't end up finding anything. So that won't be a case. So that's all they have in like in our constraints. So now it seems I don't think it's too hard to think of how we can go ahead with. Simply let's write some 2-3 lines to solve this code, and then I will explain again how we solve this as far what we thought of the way of solving this. Okay, let's write the code. So that's it, guys. You can see that this is a 6 millisecond solution. Let's understand the what we exactly did in this question. We first checked if the p-val is less than root val, and remember this is and q-val is less than root val. So if both the values are on the is less than the current root value, then we should go with root dot left. Okay, then we should go on the recursion loop with the root dot left. Okay, in the left subtree. In the other case, if the p-val is greater than root value and q value is greater than root value, if this holds, like if both are greater than the current root value, then we should go with root dot right. Okay. If that's not the case, like both are not on same side, or anyone is equal to the root, or both are on the different sides. Okay, if those kind of condition arise, we simply return that this is the root. No words spoken. This is the root. Go ahead. This is our lowest covariance system, and that's the perfect way to do it. And you can see that this works pretty fine. This gets accepted as a solution. So that's the whole idea behind this question. I hope I can make you understand how we can solve a question like this. If you have any doubts, make sure to comment them down on the comment section below. I'll be happy to help you out. Also, all the description, or all the description of this problem, or everything related to problem, will be there in the description section. Make sure to check that out for other details about this problem. And make sure to like the video also, so that it gives a better reach to other people, to understand that. And also don't forget to subscribe this channel for regular LeetCode videos like this. So thank you all for watching this video. I hope I can make you understand how to solve this kind of questions. So hope to see you soon in my next video as well. Thank you.